Hello everybody, I'm Nick, and in this video I'm going to show you how you can get started with messaging in .NET using a Nuget package called Wolverine. And when I say messaging, I'm referring to asynchronous messaging, so imagine a queue or a pub sub topic scenario. Now, in this video, I'm going to focus mostly on queues, and everything you're going to see now is applicable both to service-to-service communication. So service A pushes a message to a queue and then service B picks it up, but also within the same service. So if, for example, a user is registered into your service and you want to fire an email later, maybe from the same service, if it is a monolith or a modular monolith, you can publish something in the queue and something within that service picks it up from the queue. Not only that, but this library also has a mediator type functionality for in-memory message processing. So you're gonna see all that in this video. We're gonna see how we can use it with multiple other providers, for example, RabbitMQ and also AWS SQS. But everything you'll see in this video would also be possible with the exact same code with other services like Kafka or something like Azure Service Bus. Big thank you to AWS for sponsoring this video. If you like that content and you want to see more, make sure you subscribe for more training. Check out my courses on dometrain.com. Okay, so let me show you what I have here. And by the way, Wolverine, you should think of it as a library that comes into the picture similar to how N Service Bus or something like mass transit would come into the picture for your application. It just tries to abstract all the nitty-gritty of messaging and gives you a nice interface, a nice developer experience for you to go ahead and publish messages and consume them. That's all there is to it. So I'm gonna go to this Wolverine demo over here, and I'm going to show you how easy it is to get started. That's the one thing that I like about Wolverine, is how quickly you can hit the ground running. But also one of the things I kind of don't like about Wolverine is how opinionated it is about how it does things. For example, Wolverine, when you say use Wolverine, and we're gonna see that in a second, will actually replace the built-in DI container with Lamar, which is from the same creator. The creator seems to be very opinionated. I don't like many of those opinions, but what I see with Wolverine seems to be more positives than negatives, so I'm happy recommending it. Now, before I move on, I'd like to let you know that we just launched a brand new course on DomeTrain called Getting Started with Modular Monoliths in .NET, and is authored by the legend Steve Ardalis-Smith. I'm sure Steve has taught many of you already with courses on other platforms like Pluralsight, but now he authored his first of many courses on DomeTrain, and it's all about how to get started with modular monoliths. Not only will he teach you the theory behind the concept and how it compares to microservices or traditional monoliths, but he will also build a whole system in that course, hands-on, with code and diagrams and examples, and you can follow along. It is an amazing course, and it is the best way to get started with modular monoliths, hands down, in .NET. Now, to celebrate the launch, I'd like to offer the first 500 of you a 20% discount, so either use a link in the description or apply code modular at checkout to claim the 20% off. It's a great opportunity to get started with a concept, and I can't stress enough how much of an amazing author Steve is. Now back to the video. So let's first have an application builder over here. So I'm gonna say host.create default builder. And if you're wondering where this is coming from, I've already installed a Nuget package here called Microsoft.extensions.hosting, which allows me to create applications like this. This is not a web app. This is just an application with a host. So then, similar to how you'd have a minimal API approach, you have the app, so builder.build, that gives you back the app, and then you can say app.run. That's about it. Now, what I'm going to do is show you how easy it is to use Wolverine. So first I'm going to say Wolverine fx, and I'm going to add the Nuget package. So that's the core Wolverine package. And by default, it doesn't have any transports or means of transportation of your messages other than the built-in one, which is an in-memory version. Now, how do you use Wolverine? Well, simply you say builder.use Wolverine, and that's about it. By default, it just configures all the defaults, of course, and it has the in-memory processing built in. Now, what I'm going to do is I'm going to create a message, something I'm going to be publishing. And in this case, I'm going to have a message called create customer. So I'm gonna say GUID as the ID, a string as the full name. So in this case, this message is written in a way that is saying that I want to do something. I'm commanding, I'm ordering for an operation. It's sort of imperative, create a customer, do something. when you have that, you're sort of standing in point A and you're saying, that's what I want to do. And at some point later in the pipeline, point B will pick up that message and do something about it. In this case, hopefully create the customer. You can also have the other approach where you say customer created and you publish an event and you announce it and you say, hey, that happened. And if anyone is interested, they can pick it up and you can have this sort of multiple consumer scenario where when a customer is created, one service is putting something in the analytics, but another service is sending an email, but another service is scheduling a birthday reminder email or something along those lines. Here we're going to start with the service A or endpoint A, and I'm going to say something to endpoint B as a message using a queue mechanism. Now for my publishing, I'm going to create a background service, and that's going to be a background publisher. So something in the background will be publishing, and I'm going to have that be an I background service, which will have and execute async, and then I'm going to have a loop that every 2 seconds publishes a message. Now to publish a message using Wolverine, you'll have to inject the private read-only I message bus. So I'm going to say message bus here and inject it from the constructor, and then I'm going to have my loop. So while the stopping token is not cancellation requested, then have a 2-second delay. So I'm going to say await task.delay for 2 seconds. Of course, I'm going to have to turn this one to async and also pass the cancellation token so I can gracefully cancel my application if I want to. And then I'm going to say message bus.send async. I'm sending, I'm not publishing. I'm saying this goes somewhere. And then I'm going to have my message, the create customer. And I'm going to pass just the GUID, so new GUID, and then the full name will be Nick Chapsas. And that's about it. So I'm going to say await here and fix my spelling mistake on my name. And that's about it. That's all you need to do to publish a message. Now, you might be looking at this, especially if you have experience with other messaging approaches or messaging libraries, and you say, wait, this doesn't implement iMessage. This is just a record. This is just a class. And yeah, that's all you need in Wolverine. You don't need to implement an interface or a class. You can just have the plain old C# object, and that will be picked up automatically by Wolverine based on convention and potentially further configuration if you need to. But the class itself doesn't need explicitly anything else. You don't need any Nuget packages, and that means you can take that object and put it in a messaging contract library that you share within your team, and that doesn't need to have a Wolverine dependency. It can just be like any other contract library. And what's interesting is that obviously now we are publishing something, but we need to consume it as well. The consumers follow very much a similar approach. So you can say create customer handler, and that will handle that message. So if I need to consume it, all I need to say is public async task handle, and then pass down the type I want to handle. So create customer. And that is it. Now, obviously, this needs to be public to be handled, so I'm going to turn it into public. But yeah, that's all there is to it. It doesn't need to be iHandler. It doesn't need to be anything beyond that, which is both cool and also a bit scary for some people. Some people like naming convention and sort of duck typing. Some people don't like that. C# and .NET in general has both. We both have duck typing. Think of middleware, for example. Yes, you can have the I middleware interface, but you can also have it based on convention. So because it sort of exists in the library and the BCL, I'm not too mad about it. In general, I prefer building on a contract because it makes me feel safer. But I want to know what you think, because there is actually a reason why this is the case and why we can have this. And the reason for that is because you can actually have multiple handle methods for different types in a single class, which is pretty neat, but I wouldn't do it because I want each class to be handling a message in a very specific way. So now that we have this, let's say we want to inject a service to print the message in the console log. So I'm going to say logger, and I'm going to say create customer handler. So DI will be working. I'm going to inject the logger, and all I'm going to say is logger.log information. And this is not how you should be doing logging, but just for argument's sake, I'm going to say create customer.toString. Don't do this. If you want to do this, you should break down the parameters or use the @ symbol to deconstruct the object. But the reason why I'm doing this is to treat this as a console log, but showing you how you can inject a service. And actually, I can have this be an iLogger. Why not use the interface instead? And that's it. And just by doing that, of course, this doesn't even need to be a sync task, but it can also be void, as you can see. And that's all there is to it. So all I need to do now is register my service, the hosted service. So I'm going to say X and then add hosted service. That's the background publisher that's going to be publishing a message every 2 seconds. So let's do that. And then that's all I need. If I just say run, what you're going to see is I'm going to be publishing a message every 2 seconds. And then what you'll see is successfully processed messaged from that local queue, the create customer run. So this is happening now every 2 seconds, and you can see my console moving. And that's minimal configuration, nothing really. You can just think of this in a way as a mediator replacement, the in-memory version of messaging. But the great thing about this is you can take the exact same logic and expand it to use different transports. Now, there's a few things I want to show you which are pretty neat. For example, you don't need to inject from the constructor on your handler. What you can do instead is you can just comment all this out or just delete it in your case. You can turn this into a static method and you can simply pass it down here. And what's going to happen is Wolverine will understand that this service is coming from the DI container. So if I just do that and I say run, we will still work as we used to work before, and the service is injected from the DI container successfully. I didn't have to do it from the constructor. Some people like this, some people don't like this. The reasoning behind it is because minimal APIs kind of do this already. It goes with the same flow where you support both the constructor, but you also support the method injection as well. Completely up to you, but it means you can have this as static. And the idea is your handle methods should be pure, meaning that handling a specific set of requirements, for example, the create customer or any other parameter, should deterministically produce the same results without any side effects is possible. That will give you a very safe, a very secure and very clean way of handling your messages. Now, just because it's probably what you're mostly used to, I'm going to go back to the constructor injection, but you can choose to use whichever one of the choices you want. And documentation of Wolverine is pretty good. So if you need other ways to play around it, I'm going to link documentation down below if you want to check any other niche use cases as well. Now that is great and all, and the in-memory stuff work fine, but let's take it up a notch and let's go ahead and wire everything up on a real application. And in fact, we're going to have 2 real applications. We're going to have a movies API, which will use an in-memory database to allow me to create movies, get movies, delete movies, and update them as well, but also have a movies consumer that can do something retroactively when a movie is added or deleted. So give you more of a better representation of what you would have probably with a microservices scenario. So I'll go ahead and delete everything. And then what I'm going to do before I add Wolverine is show you what we're adding Wolverine into. So let's go ahead and run this API, go to Insomnia, and as you can see, I can go here and I can say create a movie. The movie I'm going to create is the classic Nick the Greek from 1993. It's a comedy, of course. So I'm going to say create, and as you can see, the movie was created. I can say get all movies. If I send, I can get all the movies. I can say get a movie by ID, and if it doesn't exist, I'm getting a 404. But if I pass down the right GUID and it does exist, I'm getting the movie. I can update it and then I can delete it. So for now, what I want to do is when I create a movie, I also want to publish a message. Now, there's sort of 2 trains of thought here. I'm going to talk about both of them, and I'm going to show actually both of them because Wolverine has another very neat feature. So I'm going to go ahead and stop this. I'm going to go to the Nuget packages and say Wolverine FX and just install that for now on the API. And then go to the program.cs and say builder.host.use Wolverine. So I'm going to go ahead and wire that up in here. And for now, I'm just going to leave this as it is. And then I'm going to go to the program.cs over here on this other service, which in this case, it's a web application, but it doesn't have to be. The reason why I have that is because usually I expose health checks through my background service runners. And it's very easy to have just a health endpoint and a metrics endpoint on that if it's a web application. It doesn't have to be, but it can. And I'm going to also add Wolverine there as well. So I'm going to do that and say use Wolverine, and that's about it by default. Now let's focus on the API for a second. The first thing I want to do is simulate how I would use this imperative approach to create a movie asynchronously. Now, I'm sure you've seen in some scenarios, in some APIs, when you say do something, create a resource in the system, where the API doesn't return 201 created, but it returns 202 accepted, meaning I've accepted your request and I'm gonna do something about it. Now, you have two options when you have something like this in your application. One of them is to go to the program.cs where I have all my endpoints, and let's say I wanna create my movie, and then go to the movie service, and in the create method of the movie service, I'm gonna say private read-only iMessage bus, and I'm gonna inject that in the movie service. And after the thing was created over here, so the thing was created, I'm gonna say, hey, publish this message or send this message to the bus. But this is more of a publishing act. This is more of me announcing that something happened. I'm not commanding for something to happen. So if I was to use this here, I would say publish async that a customer or a movie in this case was created asynchronously, and something else later will pick it up and do something about it. The alternative that some other people do is that they inject the service in here, the message bus service, and then they just send the act of, hey, create a movie from here, then they quickly return accepted, and that movie can then go ahead and be created asynchronously. How you want to do this is completely up to you and your requirements. What I'm going to do for the remainder of this video, just to show you both approaches, is in here, I'm going to say movie created, but I'm going to just send that message async to some other queue, the queue that will have all the movie actions. Now, from a resilience perspective, be very careful, because usually what happens, especially here, is a movie could be created in your API over here, but the message might fail to send. So what do? Well, Wolverine has a retry mechanism, and you can lean into that, and you can let it retry your message as well to be republished in the queue as it can. But this is always a bit tricky, which is usually why nowadays we see way and way more a situation where you save in the database, and then the database itself has a triggering mechanism to publish that message. We see that with things like Azure Cosmos DB or AWS DynamoDB, where you can listen to changes on the respective change feeds, and then maybe with a Lambda, put a message in a queue for further processing. I don't want to make this overly complicated, so I'm going to show this in a simplified version, just so you understand the tooling. But know that in production, in reality, there's way more that has to do with resilience in these scenarios. So now I can send the message somewhere, but I also want to consume it. So I'm going to go to the consumer over here, and I'm going to say, let's go ahead and create a handlers directory. And in there, I'm going to have the create movie or the movie created handler. So this will have a public async ask method called handle, and I'm going to have the movie created contract over here, which I have shared in a library over here. So both API and consumer are using it. Now I don't want to do much here. So all I'm going to do again is just print in the console. So logger movie created handler goes here, logger, inject that, and just print it in the console. Again, never do logging like this. Never just say toString, destructure it and store it properly. I'm just doing this for demo purposes. Or again, this could be void since we don't have anything here that needs to be asynchronous. And that's how simple for in-memory stuff this is. But we can't really do this in memory because now we have two different services. We have the API and we have the consumer. So we kind of need a means of transportation for those messages now. And what we're going to use in this case is RabbitMQ to start with. So RabbitMQ is an open source and extremely popular message broker, which is implementing the AMQP protocol alongside some others now, but fundamentally, originally, that was all it was about. And you can just run it locally using Docker if you want, or have a hosted version. If you get the source code from the description down below, you're gonna have a Docker Compose file alongside all this code to run it locally if you need to. So in my case, I'm just gonna say Docker Compose up over here, and that very quickly will create a RabbitMQ instance over here. Not only that, but I'm also going to get an interface to examine my queues. So after you run this, if you go to localhost 15672, you can say guest, and you can log in and you can see your channels, your connections, your queues, your exchanges, and so on. You don't need to know everything about this, but as you can see, we have some default exchanges. We have no queues by default, and we're gonna let Wolverine manage all that for us. How? Well, with a RabbitMQ specific extension package. So first, let's configure RabbitMQ on the API layer. So I'm gonna go to packages and find the RabbitMQ package over here and install that. And once I do that, I'm gonna go ahead and just use the extension method or the configuration approach over here with this lambda and say, use RabbitMQ. I want this to publish a message of type movie created. And by the way, you can also say publish all messages where you're not specific about where each message goes. But just to give you a bit more transparency, I'm going to say publish message movie created to Rabbit exchange, not the queue, not the topic, just the exchange, where then the exchange can put it in a queue, and we're going to configure that as well. So I'm going to say movies exchange, and then I'm going to configure the exchange transportation. So I'm going to say exchange type is direct, and then exchange dot bind to a queue. So from the exchange, take it to the queue, and that queue name is movies queue over here. And this binding key here will be exchange to movies. And that's about it for configuration for the publishing. Again, you could do all this, and in this case, since the queue will be used for all messages and you're only gonna publish movie messages, you would also say publish all messages to the movies exchange, and then that will take them to the queue. And then after that, you can say use RabbitMQ over here. That will have its own configuration. All I'm gonna say is that the host name is localhost, since we're running it locally using Docker. And that's about it for the configuration in here. The last thing I'm gonna say is auto provision. So automatically provision the resources in RabbitMQ, and that is queues, exchanges, and so on, without me having to go manually in RabbitMQ and do it myself. And once I do that, let me show you what happens. I'm gonna go ahead and just run the API. I didn't change anything else in my code. The same publishing code is still in place, but as you can see, a few things happened over here. Some things were created. And if I go to RabbitMQ, you're gonna see now we have a movies queue over here, which has no messages, but it has some bindings. In this case, it is the exchange to movies bind, where we get the movies from the exchange into the queue. And we can say, go ahead and create this movie. And once I create this movie, a message is published into RabbitMQ through Wolverine. So I can go here, go to the queue, and in the queue, you can see I have one message ready now to be consumed from something. That is the message just published. And of course, I can say here, for example, get messages, and I can get the message, and I can see exactly the payload of the message, because the message, again, is the body of the message, but then all that is wrapped in an envelope containing other metadata. For example, all this is metadata of the envelope. Now, how do I consume this from the consumer? Extremely easy. Same logic as before. I'm gonna go ahead and add the RabbitMQ package, and I'm gonna copy all this configuration. I'm not gonna use all the configuration, but I'm going to use most of it. So let's go ahead and say this. I'm gonna say that I'm not actually going to publish anything from this service. So I'm gonna remove all that. But what I will say is listen to RabbitMQ. So listen to the queue with name movies. And this won't be needed from 2.0 Wolverine, but you can also say use for replies over here. I'm not gonna go too much in depth into that. You don't really need to know much about it. And once I have this in place as well, I can go ahead and I can say run the consumer, and presumably we still have one message in the queue. So if I go back and I refresh, you can still see that message over here. Nothing acknowledged it and nothing deleted it. Just getting the message doesn't mean it goes away. So I'll go here, I'm gonna say run the consumer. The consumer will run, hopefully we'll find the message and consume it and print it. And as you're going to see, yes, successfully processed message of that type. And you can see that the object was movie created with all of these information. Fantastic, extremely easy, extremely simple, awesome. Now, one thing I wanna point out, which I didn't mention earlier, RabbitMQ has this ability to retroactively publish a message if the return type of the handle method is also an object type. What do I mean? Let's go away from this movie stuff and go back to the original demo example. So I'm here with a create customer. So what I say is I want to create a customer, but after I create it, I want to say that the customer was created. So publish this event, this action with these details. Different actions. One is do something. The other one is something happened. So what I can do in the handler is, let me just duplicate this handler and say customer created handler. Now this handler, the customer created, will return the void or the nothing. And we're going to use the customer created object over here. So customer created. But on the other one, the create customer, it's not going to return the void anymore. No, what it's going to do is it's going to say return a new customer created object with the following parameters: the create customer ID and the create customer dot name. So now the handle method has a return type, and this can also be async task, by the way, which means that every 2 seconds now, I'm gonna first publish the create customer request or action, but because I'm returning the customer created, and we just quickly stop it, as you're going to see, I'm both publishing the create customer, but I'm also publishing automatically this customer created object because I'm just returning it. And you can use that to have cascading messaging where one action triggers another action triggers another action. Very neat, very cool. You can fall into issues with this approach, especially if you caught yourself in an accidental loop or you refer to things that you shouldn't do in different layers. But overall, I think this is a great feature. So keep that in mind. This will also work with messaging providers or transport. So that's cool. I can have RabbitMQ here and now that's all amazing. But what if I want to take it in the cloud? Or what if I want to just use a different transport altogether? What if I want to move from RabbitMQ and go to AWS SQS, for example? How much will my code need to change? Well, not much at all, actually, because that's the whole point of libraries like Wolverine. So what you would do in that case is you would go over here, you would remove the Wolverine package, and you would add the one you need. In this case, Amazon SQS, which is the queuing provider for AWS. And you don't need to change anything but this method to say use Amazon SQS transport, as you might imagine, and publish all messages won't go to an exchange anymore, but instead they're gonna go to an SQS queue with name movies queue. And that's it. You don't need to change anything else. I'm going to go to the toolkit over here, the AWS toolkit, and I'm going to show you have no queues as well. Auto provisioning will still work for each respective type. And that is awesome. So let me just quickly delete this old using statement. We don't need it anymore. And of course, I need to reconfigure everything in the consumer. Thankfully, extremely easy. So add the Amazon SQS approach and remove the RabbitMQ one. I don't need that anymore. So I'm gonna say you go away, you also go away, and then this turns into listen to SQS queue. So the naming of methods is consistent no matter the transport, making it extremely easy to follow. So same thing here, use SQS transport. And you can also have, by the way, the use SQS transport locally. So if you use something like local stack, which is a way to run AWS infrastructure locally through an emulator, this is amazing. This just works out of the box. So let's see how that would work. I'm going to go ahead and run the API first. I haven't changed anything than the configuration. And as you can see, the queue was created over here. And also a dead letter queue was created. So if a message went ahead and failed for some reason, after all the retries, it will end up there. So in the toolkit, as you're going to see now after I refresh, I have my 2 queues. They are empty. There's no messages to view. So what I'm going to do is I'm going to just run the consumer as well in real time. That will also use the exact same queue and will try to create the queue if it doesn't exist, because I said, well, go ahead and use it. So let's go and create the movie. And as you're going to see in the consumer, the message was published into SQS, and then it went to SQS and consumed by my API. So easy, so simple. I didn't need to do anything. Again, I can stop the consumer and I can create a bunch of more movies, of course, with a different name. So let's have the sequel, same year. Let's have another one, and let's have another one as well. Here we go. So all those messages are not lost. If I go to the toolkit, you'll see that they are still here. I can say view messages, and the toolkit is a bit delayed, but it shows me, and I can click here and see the body, and I can see everything about the message. And if I go and I say now run the consumer, the messages still stay there, and asynchronously they are processed in my application. And as you're gonna see now, all of them were immediately published. And any provider you're gonna use, any transport you're gonna use, also has transport specific configuration. So things like listener count, if you want to have 5 listener competing consumers, all that will just work out of the box. It is configured based on each provider. Currently, the supported providers for Wolverine are the following. So you have things like MQTT, Kafka, you have SQL Server, so you can actually use a database for that. You have RabbitMQ, Azure Service Bus. You also have a built-in Fluent validation module. So if I actually have that over here, let me just quickly show you, because I think it's pretty neat. You can say use Wolverine, but you can also say use Fluent validation, and you can have validators for your messages, and they can be validated before they are sent to the queue. Very neat, very nice. I like that. I think it's a great idea, especially because it's in a separate Nuget package. So if you don't need this, you don't opt into it. But if you do need it, you do opt into it. I think compared to libraries like Service Bus, for example, this approach is way better. I actually was thinking of making an Service Bus video, but I found the interface so old, archaic. It felt like I was working with legacy code. So I really hope Service Bus actually fixes that as well. And if you want to see a video on Service Bus, please leave a comment down below and let me know. I would still do that because I know many people use it, but it's not really an enjoyable experience using it. But now I want to know from you, what do you think about this and what are you using? Are you using Service Bus, Mass Transit, Wolverine, something else? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding.